All right, we're going to go ahead and get started. Welcome to today's CNCF webinar, What's New in Kubernetes 1.13. I'd like to thank everybody who is joining us today. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. However, there is a QA box at the bottom of your screen. So please feel free to drop your questions in there, and we'll get to as many as we can towards the end. This session is being recorded and will be sent out afterwards along with a link to the presentation. With that, let's go ahead and get started. So today we are going to be looking at what's new in Kubernetes 1.13. We got a few people here on the panelist side. Myself, Kendra Coleman, I'm the 1.13 enhancements lead coming from VMware. Saad Ali is going to take care of storage. She's coming from Google. Caitlin's with us. She was the 1.13 communications lead. Then we also have Tim St. Clair of Heptio as well as VMware now as well. So one of the few things that we want to get to on our agenda today is looking at the enhancements overview. As I mentioned, storage updates, kubeadm, and if you have those questions, make sure you use your Q&A button towards the bottom. So the 1.13 enhancements. We're going to talk first on some major themes of really what we saw in 1.13. It was a big focus on stability. 1.13 release cycle was reduced from a typical 12 to 13 weeks down to 10. And this is because there was the US holidays as well as 2 KubeCons that were there in the middle. And with that, we had to be able to create something that was able to get something out the door in a reasonable amount of time. In addition, to make sure that we are able to achieve a lot of the releases was to remove some of these lofty goals in regards of anything that was huge to be able to put in there. So one of the things that we really looked at were looking at features that had slipped from 1.12 and making sure that those had priority getting into 1.13. This also did require extensive communication, and this was coming from the release leads and then going into each of the individual SIGs themselves and having a communication dialogue of saying this is what was to be expected and this is what's going to happen. At the same time, being able to look at what features or enhancements were being developed into that particular SIG and seeing sort of what the status was and making that happen. Now, another major theme that you're going to be seeing as Kubernetes continues to advance is continuing to de-vendor the central code. And this is actually removing a lot of the vendor code that's related to individual vendors that are out there and instead actually make that more extensible. So you're going to see a lot of things that are new as well as things that have been graduated to allow vendors to be able to start plugging into particular interfaces instead of actually having been baked into the core of Kubernetes itself. So just an overview of what it looked like in regards of what features, enhancements were added. You have 9 that came in as alpha, what were net new. There were 8 that were graduated to a beta classification, meaning they had graduated from alpha to beta. And there were 6 that had graduated from a beta to a stable classification as well. So 23 new enhancements. And since we did have this aggressive timeline of getting this release out the door, you can see that there were actually 25 enhancements that were removed. Greater than 50% of the enhancements that were originally tracked were deferred, and you can expect to see some of those start hitting in the 1.14 release. So let's go over some of the highlights. What were the major key themes, or what were the major updates that we really look at, especially when it comes to things that are going to touch a wide range of users out here? And when we talk about this, a lot of these are going to be focused on things that hit GA or stable. First is kubeadm. I'm not going to talk too much about this because Tim St. Clair is going to be on here towards the end, and we'll go a lot further in depth about really what this means and what this means to the community in general, and a lot of the technical pieces behind it as well. Just know that this does live outside the core of Kubernetes, but it is being developed in parallel to stay up to date with a lot of those new releases that are coming out. And this is going to be one of the tools that the community has really rallied around as one of the preferred methods for bootstrapping a Kubernetes cluster. The other is CoreDNS is now the default DNS plugin. This was actually first introduced into Kubernetes in 1.11 as an option, but slipped from being a default in 1.12 because it was failing some scalability testing. just for some background, one of the tests ran during a SIG release process is that there's a 5,000 node test. And since that wasn't passing, we had to be able to defer that, but it came in for 113. CoreDNS, if you are unaware, it is a CNCF project. It currently has over 3,000 GitHub stars, over 114 contributors, and it has some unique features such as being able to listen to DNS requests over gRPC. The DNS role within inside of Kubernetes is to actually do internal name resolution between nodes and pods. CoreDNS has a few other benefits to it as well. It has a fewer moving pieces than its predecessor, which was kubeDNS. It's also a single executable and a single process. And one thing that I would imagine everybody loves to hear, that it is written in Go. So with it says that it's also memory safe. It also supports some more use cases. So if you want to add custom DNS entries, stub domain support, you want to serve DNS based on label selectors, wildcard queries, and more. So looking forward to seeing a lot more use out of CoreDNS going forward. As I mentioned, extensibility is one of those key pieces that are coming in here as well. And this is really looking at the kubelet. And the kubelet needs a standard way to discover local plugins, whether it's for CSI, CNI, GPU, etc. This is going to change the current process, which had originally registered to the kubelet through gRPC and had a new module. And now what we have is we actually have a new module that's going to be watching for changes on a particular path to the system. So this recursive searching is going to look for new sockets within inside the path. And when a new socket is found, the watcher module will get details and will now register the new service to the kubelet itself. I'm going to go ahead and let Saad take this because this is a big one, again, about extensibility with the introduction of CSI coming to GA.
Thanks, Kendrick. So CSI, to set the stage, this is the culmination of a year's worth of work. CSI was first introduced in Kubernetes in the 1.9 release in the Q4 of 2018. And this last quarter in December, and part of 1.13, it finally became GA. To set the context for what it is and why it's important, you're all probably familiar with the Kubernetes volume plugin layer, which provides a very, very powerful abstraction for both file and block. It automates provisioning, makes it easy to automatically attach and mount your volumes wherever your containers are scheduled. But the challenges are that it requires the code for these volume plugins to actually be part of the Kubernetes binaries, which means that it's actually difficult to extend and add additional new volume plugins. And so that's the problem that CSI has been aiming to solve. The project evolved out of a cooperation with other orchestrators in the ecosystem and has broad industry support amongst storage vendors. It actually ends up making Kubernetes, the Kubernetes volume layer, truly extensible. There are over 20 volumes that are currently available to use, and we're going to see more and more as we continue. And that's it. Back to you, Kendrick.
Great. Thank you, Saad. Now, another one that I want to be able to bring up because it's always a hot topic is, where is Windows container support? Windows container support was actually on track, was being watched pretty closely with inside of 113. It's good to know exactly sort of where this is with inside the ecosystem and where the community really feels where it is as well. So during this process, there was a meeting between SigArch and SigWindows to really look at the current status. And however, it was determined that it just wasn't ready to graduate to a GA or a stable release at this point. So there's an error request and a formal KEP has to be filed. If you're unfamiliar with what the KEP process is, it's the Kubernetes Enhancement Proposal. You can read more about it with inside of the Kubernetes/enhancements repo. And from there, a KEP needs to be tied to every enhancement going into Kubernetes going forward. So this is to make sure that there is an expectation of what will and what won't be supported when it comes to this particular enhancement. In addition, it also gives the ability to have a community consensus of everything going forward. So we're going to look into individual SIGs and what their enhancements were as we go forward here. So the first one we look at is API machinery. So the API server dry run graduated to beta, and this is a feature that's been implemented with inside of the API server in itself. It sends requests by specifying a dry run flag, and that is going to put a query and a CRUD call to see what would or what could have happened. So everything's going to run normal except for storage wouldn't be modified. Everything else would work as expected. Admission controllers run a check to see that a request was valid. It's going to mutate some controllers to change an object. A merge will be performed on a patch, and then the storage layer will be informed not to stave. But the final object returned to the user would be a normal code status. And this is great if you're a developer looking to test out new deployments, or maybe you're creating new plugins that use things like a default storage class, webhooks, a resource quota, priority, and more. The webhook conversion for CRDs is now entering an alpha stage. CRDs are becoming a crucial part of the Kubernetes ecosystem, especially as individual vendors figure out how to put their own special sauce within inside of Kubernetes in their own deployments. And if you're unfamiliar, just a resource in itself is just an endpoint in the Kubernetes API, and it stores a collection of API objects that could be of a certain kind. So for example, the pods resource is just a collection of pod objects. A custom resource, however, is an extension of that Kubernetes API that doesn't necessarily mean it's available on every Kubernetes cluster, but represents sort of customization. Now, the existing problem is when a webhook needed to make a request to another service, but now the APIs have potentially progressed or they've changed. This webhook conversion allows developers to evolve their API while still maintaining backwards compatibility of those versioned API resources. So this allows objects or services to hold multiple versions and at the same time convert a webhook from one version to another based on that particular need. etcd2 has now dropped from Kubernetes 1.13. If you're unfamiliar, etcd it's actually used by a lot of different components within inside of Kubernetes. This could be from the API server all the way down to individual test jobs. etcd2 was the long supported backend, but it didn't fit all the required use cases as well as scale. The deprecated status was actually announced back in Kubernetes 1.10, so that gave a lot of feature owners plenty of time to start figuring out how they're going to transfer or start utilizing etcd3 in all its forms. To kind of give some real world experience, there was a Kubernetes mailing list where Clayton Coleman called out, and he said that they were running a million key value stores somewhere around, a million key pieces where there's 10,000 namespaces, 20,000 pods and services, and they were running on Kubernetes 1.5 with etcd2, and they were effectively completely bottlenecked on write and read traffic at this particular scale, because you're looking at roughly 1,000 requests per second to etcd. So looking forward to a lot of things that people can come up with etcd3 coming for the future here. Moving on to SigAuth. So dynamic audit configuration is new for alpha. Kubernetes by itself already has auditing built into it. And this is really a security focused mechanism that provides a set of records that document activities that are being performed in the system. This could be from individual users, administrators, or even components themselves. And it allows an administrator to be able to answer the questions like, what happened, when did it happen, or who did it? The KubeAPI server performs that auditing, and before each request executes, it generates an event and is written to the back end. Now, the dynamic portion of this is to allow advanced auditing features to be dynamically configured after the cluster has been provisioned. Now, the reason this is needed is because it's difficult to accomplish, since the configuration typically requires some sort of insight into the deployment mechanism of choice. And you also need to install more tools that are needed for future knowledge of actually how to reach them when the cluster is live. So this can be used for particular use cases where a cluster admin might want to enable an internal audit trail or configure multiple audit policies to provide independent auditing during the provisioning aspect in itself. Now, SigCLI has a few different interesting components themselves. The CubeCuttle diff is now graduated to beta, So as a user in itself, this will be great use because different object configurations may exist for the same object in a Kubernetes cluster. So here's a particular kind of workflow about how this would work. So say you're running an apply on a local object configuration. It's going to result in a live object on the cluster that's being created or updated. Now the local object configuration is saved as what's considered the last applied object. Next, you're going to update the live object configuration from a local object configuration in a new merged configuration. And now that becomes the new live object configuration. Now, if you didn't catch all that, it essentially allows you to run a diff on a running object versus one that you would say in baseball terminologies have one in the bullpen. The plugin mechanism from CubeCuttle is really getting to more extensibility, allowing even greater use of Kubernetes, but now unifying it on the CLI in itself. So you could say you could build a plugin that would interface with individual API calls of an object outside of Kubernetes. Basically, you're building a shim that hits a Golang interface and performs varying functions. So we can put functionality for individual components to the CubeCuttle command line. Just an example, think of something like extensions for storage integrations that you want to manage it remotely. You could create a query that examines remaining storage available on a device before attempting to create a new persistent volume. So there's lots of options here that you can build a lot of nice integrations and even extend Kubernetes even further. So moving into SigNode. Now, this is, again, falling into more extensibility. There's a whole ecosystem that's built around performance management and monitoring, and even device monitoring itself typically used to require external agents because they had to determine what devices are in use by those containers. So some types of these could include container logging exporters like FluentD, container monitoring agents like CAdvisor, and even device monitoring plugins like from NVIDIA with their GPU monitoring plugin. Now, each of these agents faces a similar problem. If you get a metric or a log associated with a container, how can this information with metadata be filtered by namespace, pod, container, whatever? So the goal is to remove device-specific knowledge from the kubelet and requiring that to become out of tree. So as a cluster admin, I know that every device is pulling data from a particular agent, but in doing so, I can do it in a compatible fashion that doesn't require like a myriad of implementations. So now device vendors can provide tools that live out of tree. And again, fitting with the theme of extensibility, they're not gated by the Kubernetes release cycle. Now, moving frequent heartbeats from the kubelet to the lease API is a new alpha feature. This is necessary. If you're not familiar, node heartbeats are necessary for a functioning Kubernetes cluster. Scalability testing had discovered that clusters with more than 2,000 nodes that have a small number of images that are used by pods on varying nodes were hitting some etcd limits for database size. And when that happens, that means etcd stops accepting those write requests. To give you some sort of idea, node heartbeats can be potentially large objects, somewhere around 15 kilobytes in size, and they're done every 10 seconds. And that doesn't even include the node status updates, and that can result in nodes being marked as not ready. This new implementation reduces the size of heartbeats by using what's called a lease object. And the leader election object uses the microtime go package as the initial record to become the node heartbeat. And now each node will actually have to correspond to the lease object in a dedicated namespace. The lease object in itself is going to be updated every 10 seconds, and it's going to reduce the frequency of node status updates to 40 seconds. Moving on to SigScheduling. Taint-based eviction has been around for a while. Tainting nodes has been around for a while. Taint-based eviction is actually graduating to beta. And if you're unfamiliar with what tainting nodes is in Kubernetes, it's something that maybe in other terminology, in other realms, maybe it's considered like anti-affinity. It ultimately means that we want to restrict, or we want to prefer to restrict some certain workloads from being scheduled to specific nodes. Now, taint-based eviction really builds upon this because it's enacting rules automatically, and it will immediately evict those workloads, especially if there's a node state change that's going to be happening. So for instance, if a node is sensing a network or memory pressure, and then a taint is added to that particular node, workloads are going to begin to start placed elsewhere, or the taint itself is not going to allow any new workloads to be placed on that particular node. And as you can see on the slide, here's all the different types of uh, conditions that you can actually put on them as well. So the scheduler checking for feasibility scores in a subset of all cluster nodes. Now it sounds like a lot. This is actually moving to beta, but it's an enhancement to the schedule algorithm, and maybe it'll go unnoticed unless you're running lots of pods within inside of your clusters. Or maybe you're hitting some performance issues that require something down to maybe the millisecond. But what used to happen is the Kube scheduler looks at all the available nodes in a cluster for every pod and every scheduling attempt. Then it's going to score them to determine the placement. Now, even though it may have the highest score, it may not be the best node to use. So this new feature is going to find feasible nodes in a cluster first, and then it's going to pass those in for scoring. It's going to bypass ones that are beyond the threshold of needing to be scored. So now we're moving on to SIG storage, and I'm going to hand this over to Saad.
Thanks, Kendrick. So first up, we have a feature called topology-aware volume scheduling. This is being graduated to stable. And the idea here is to make the Kubernetes scheduler more intelligent in terms of storage. Prior to the existence of this feature, the way that the scheduler and storage worked was they didn't really interact with each other. You created a persistent volume claim object, which resulted in dynamic provisioning of a volume, and that was completely independent of the decisions that the scheduler was making. When the volume is provisioned, that volume may be provisioned in a zone, region, rack, something that is not necessarily, doesn't have compute available in it. So when a pod ends up using that PVC, the scheduler tries to find a home for that pod. It tries to find a node that is in the same topological segment as the volume, and it may be that there are no available resources in that segment, and therefore the pod remains unscheduled. With this feature, there is a new volume binding mode called wait for consumer, which delays the binding or the provisioning of the volume. So when you create the PVC object with this new volume mode, instead of provisioning right away, it will wait for a pod to reference the PVC. And when that happens, the scheduler will make basically influence where the volume is going to be provisioned by taking into account what other resources are available on the cluster. And that information is passed along to the volume plugin to intelligently schedule or provision a volume. Next slide. The second feature we have is raw block device. This is moving to beta. So previously, volume plugins only supported a file, which means that you could have a directory mounted with a file system and exposed inside of your container. There wasn't really an ability to expose a raw block device, volume device into your container. This feature was added in as alpha a few releases ago and has finally graduated to beta and is supported by a handful of entry volume plugins. It's also supported in CSI as alpha, but basically it allows a raw block device to be exposed directly inside your container. So if you have, some databases are optimized to use raw block devices, and you may have some application that for some reason prefers to access block directly. Next slide. Finally, we have a feature being added to Flex Volume. Flex Volume was an older way of doing external volume plugins. It predated CSI. In general, we are going to freeze the development of Flex Volume, meaning we're not going to add new features to it. We're going to leave it as is and add all new functionality to CSI. We're going to continue to support Flex, but all new functionality will be added to CSI. That said, there was one last feature that folks who have been working on Flex were really asking for, which was the ability to resize a volume. The ability to resize a volume exists for the entry volume plugins and is being added for CSI, and it just got added as alpha for Flex. So keep an eye out for that. And I believe that is the last storage feature. Back to you, Kendrick.
Awesome. Yes, it sure is. And we are going to go ahead and pass this over to Tim. He's going to be talking about kubeadm, kubeadm. Maybe you can give us some insight exactly how you should be saying this too.
So it depends upon who you talk to. A lot of people say kubeadm. My son likes to say kubeadm. So it depends upon the context of who you're talking to. Just for a brief synopsis for those who are unfamiliar with kubeadm, kubeadm is a tool, a composable tool meant to stand up a best practices Kubernetes cluster or an MVP for the control plane. It's meant to be the user experience is meant to be simple. It's also meant to be limited in scope and composable. So where kubeadm stops is explicitly at the control plane. It does not do sort of provisioning at the cloud provider level, right? For those higher level tools, there are other technologies that allow folks to use that. So what does this mean for kubeadm to graduate to stable? The first and foremost aspect is having a stable command line that people can depend upon. So for folks who are building higher level orchestration tools, whether that be built upon a number of assorted configuration management tooling such as Salt or if you have Ansible scripts for setting up your environment or a number of other CM tools, Terraform, you can depend upon the CLI and the semantics within inside of the CLI. So we will follow the standard deprecation policy and procedures for how we sort of modify and support that CLI. Also, we will support, as we have in the past, but we've graduated the support to be fully functional, and so folks can depend upon it for upgrades between minor versions. We've always done this for a period of time, but we want folks to feel at ease that we will absolutely guide folks through the life cycle of upgrading their clusters. Next slide, please. What's really interesting about kubeadm is that we've built it as a very composable layered model. So there are pieces of kubeadm called kubeadm phases. The phases exist underneath the init subcommand. Those phases can be executed independently. So if folks had a higher level orchestration or they wanted to custom tailor their deployment model, they could absolutely do a piecemeal implementation of certain aspects of kubeadm using the phases subcommand, which is underneath init. So what we're planning on doing also in 2019 is modifying kubeadm join phases so that way we have a similar look and feel for how a node joins a cluster. Next up, we also have completed a lot of the work around our etcd configuration and management. So you can use kubeadm to do etcd management. You can do it independently of kubeadm itself, or you can do it in a stacked master configuration, as we like to call it. Both of the instructions are documented on the main website, so folks who want to have different type of deployment topologies are supported for both. Last and not least, we've kind of done a lot of work to get kubeadm aspects of the kubeadm CLI ready for HA capabilities. This is not yet a stable feature, but we have added the underpinnings to make that possible. Next slide, please. Another aspect of kubeadm that we have graduated within the 1.13 timeframe was the configuration file format. Inside of kubeadm, there's a well-versioned and typed configuration file. It's very analogous to what internal components inside of Kubernetes call the component config. So we use API machinery to basically have a configuration file format that folks can depend upon and conversion over time. So this is important because it allows folks to easily upgrade and for us to be able to introspect version configuration information about their clusters and the different options that they've chosen for part of their deployment. And that is it for kubeadm major feature updates for 1.13. Back to you, Kendrick.
Thank you, Tim. Now we do have some time for questions. So if you like to, please drop it in the Q&A tab at the bottom of your screen, and we'll get to as many as we have time for. And we've got plenty of time, so that's the good part. But I see two questions that are here. And first is from Nikhil Jain. It said, could you please highlight the key benefits of Kubernetes on GKE versus on AWS EKS and when to use which? Unfortunately, no. And just to kind of give you some more kind of mindset of sort of where the release team is going in regards of how we even track features related to the individual SIGs themselves or individual vendors is that you've seen that there is much more extensibility that's being built into Kubernetes. It's coming from everywhere from the storage side, it's coming to the cloud provider, it's coming from everywhere. And so the idea going forward is that we are going to no longer track a lot of individual vendor enhancements that are coming within inside of Kubernetes/enhancements. The only time that actually is going to be tracked now is the deprecation status. So as Saad had mentioned earlier with CSI, you're going to start seeing a lot of the components that are already baked into Kubernetes start being shifted out into their own cloud controllers. Now, those are being tracked because we have to track them for what's being deprecated inside the core of Kubernetes and when it should be going to an external third party. However, if the external third party is creating their vendor specific driver, that's going to be taken care of either within inside their own SIG or within inside of some other tracking mechanism. So the SIG release team is not going to be looking at every single vendor that's creating every single, say, CSI driver. That's nothing that's going to happen there as well. Stefan asks, are labels like alpha, beta, postponed included when describing features in the release notes? No, not in the release notes specifically. So the best way to look at this is there are alpha, beta, and stable tags if you go to the Kubernetes/enhancements repo. Now, with inside of there, that is the tracked, those are all the tracked features or enhancements that are coming in and how you can see which stages are being graduated. With inside of the release notes, it's everything from bug fixes to those individual components themselves. So if you're curious about a specific enhancement, I'd encourage you to go to that repo and not be focused solely on the release notes that are coming from the rolled up version. The other thing to also understand is that the release notes themselves are being given by the individual, some are reports that are given by individual SIGs themselves versus ones that are collected through an automated means. Let's see. Alhami has a question, and Tim, maybe you can answer this. It says, what is the plan or final goal for kubeadm HA?
So kubeadm HA exists as experimental, has existed as experimental since for some time now across several releases. With each iteration that we've done from like 1.12 to 1.13, we have incrementally improved the user experience. There's one problem that we have left to solve that we plan to promote it to beta in 1.14, and that problem is certificate management. So there are a number of proposals that we have gone back and forth on with regards to it, but I fully expect, like everything inside of kubeadm, we plan to support folks even through experimental features, but we won't do it officially until it's gotten to the beta state. So we've been very conservative on the kubeadm side of the front when we call something beta, because we want to make sure that it's rock solid and that folks can depend upon it.
Thanks, Tim.
Answer the question.
James asks, when you say Windows container support didn't happen, does it mean one cannot try it out in a pre-alpha beta stage within 1.13? Yes, you can go try it out. It is still available with inside, its beta existence right now. It was just not graduated into a GA status. To be graduated into that particular status, the terminology is still always being defined and worked, but what it means is that it is being tested so much that there will be no breaking changes, or there will always be backwards compatibility with it that can stand long-term support. So that's essentially what a stable or a GA status means as well. Let's see what's next here. Tim, you might be able to answer this one as well. Will kubeadm upgrades support Kubernetes upgrades from version 1.10 to 1.13, or would you need to go in a sequential order?
You need to go in a sequential order, and this is well defined actually in documentation all across the website. There's, we have a formalized section underneath policy, and there's other documentation that explicitly outlines how to upgrade kubeadm proper. And the reason for doing this actually has nothing to do with kubeadm at all. It has to do with the internals of API machinery and what it means to upgrade or update resource objects across a given version. Internally, as mentioned earlier on the call with regards to CRD migration, there are facilities inside of what's called API machinery in the API server that does a conversion for different resource objects across specific versions. And there's no guarantee, and there are no tests currently, that do skip level jumps inside of Kubernetes. The complexity becomes too burdensome for us to maintain as a community.
Great, thank you. Tim, you might be able to know this because you're the smartest guy here in the room sometimes for when it comes to these particular pieces. When is the issue of multi-tenancy in Kubernetes going to be solved? Can you provide fully application isolation within inside the same cluster?
That's like asking, what does the color blue taste like? I think it depends upon what you're trying to solve and your level of multi-tenancy. There is a lot of ongoing work here in this space. And it's just a very hard problem to solve for all the different use cases and user stories. There's like what people call hard multi-tenancy, and there's like things like soft multi-tenancy. I would say that soft multi-tenancy is totally doable and possible today. I think things like hard multi-tenancy are kind of fractal in their nature on how you want to define where it stops. Like what is your boundary line for being okay with having a next door neighbor, right? And for different people, that constraint becomes a little bit different, right? So there exists a bunch of technologies today to do levels of this, but I don't think you're going to get a hard and soft answer with regards to hard multi-tenancy for quite some time. With regards to soft multi-tenancy, you can totally do it today.
And another question for you is as it regards to kubeadm. It says, does the cluster API leverage kubeadm?
The cluster API is agnostic to kubeadm, but most of the providers do leverage kubeadm. The primary function of kubeadm was to become the reusable nugget for different installers, and most of the kubeadm or most of the cluster API providers do use kubeadm at its core, as well as other installation tools, including kubespray, which the latest version of kubespray that supported for 1.13 also uses kubeadm at its core.
Thanks, Tim. Another one that's coming from Sudeep Batra, it says, can you elaborate on CRDs as in all objects within inside of Kubernetes will be based on CRDs subsequently? I don't believe so, but Tim or Saad, if you have any idea.
I can take this one. So in fact, yes. So the way that Tim Hawkins describes this is that if we had CRD machinery when we first started the project, there would be no core objects. CRD is just a mechanism for describing an API resource. In the future, we want to build up the CRD machinery to the point where it can provide you essentially the same level of functionality as the core built-in types. And moving forward, all new functionality will be added via CRDs. And in the past, if we had this, even core objects like Node would be CRDs. And the reason for doing this is we want to simplify the API server into just a pluggable component that multiple projects can reuse, and then the resources that they care about will be installed as CRDs. So on the SIG storage side, for example, we're already running into this where our snapshot feature, for example, is making use of CRDs to define the API objects that it will be using, but it doesn't make it any less Kubernetes. It's just a mechanism by which Kubernetes is going to add resources in the future.
Thanks. Another question that you might be able to answer regarding there, since you are the C, we'll put an X, I portion on there, is there a plan to support multiple CNIs within the same Kubernetes cluster? Does anybody have an idea about that?
I know a lot about CSI. I don't know a lot about CNI, so I'm not sure. Maybe somebody else on the call does. Tim, maybe?
No is the answer, typically. There might be some versions of that where people have tried to do incantations, but I would highly not recommend it just due to the complexity that's involved with it.
Thank you. Let's see, a few more rolling in. So Tim, will COPS eventually use kubeadm under the hood?
It's been talked about several times. I think the problem has to do with legacy and how much initial code was written. I forgot the name of the technology they used, but they built their own sort of basic bootstrapper underneath the hood. Justin Santa Barbara and I have conversed several times about him slowly wanting to migrate pieces over time, because he doesn't necessarily want to maintain that code. And there is a large core group of folks who are maintaining sort of that bootstrapping user story.
Thank you. Another question that's a follow-up to the multi-tenancy is, can we achieve full isolation between applications installed across different namespaces in the same cluster? There are use cases we need a group of admins managing one app that cannot access other apps in a different namespace.
Yeah, you can get full isolation with regards to network policy, if that's your boundary line for isolation. So this is where I said hard multi-tenancy gets a little strange, because it depends upon what level you consider things to be completely sandboxed, right? So if you want to be completely sandboxed, you have to get to some level of virtualization at the lowest level, or some hard boundary box by which folks can feel comfortable with at the pod/container level. But from a network policy perspective, you can sandbox today, even with things like Calico or Cilium. You can isolate the traffic so it's only visible from a given tenant or namespace.
Great, thank you, Tim. With that, I don't see any more questions that are available, and that's what we're gonna wrap up with. Thank you everybody for joining us today. The webinar recording and slides will be online later today as well. We look forward to seeing you at a future CNCF webinar. Have a great day, everyone.
Take care.